this is Key. I'm another TA of the Electrical Circuit Lab, and today in this video, I'm going to talk about some background knowledge, some theories, and details you need to know about the Lab 4 before you get started. First concept you need to know is how to calculate the power of a component. So before are some derivations, but you just need to remember this formula. There are three ways to calculate the power. And next is the most important concept for this lab. It's called the Thevenin equivalence. So as we can see here, Thevenin equivalence is used when analysis of a particular resistor in a complex circuit is desired. And this resistor is referred to as a load resistor. So basically, it means the Thevenin equivalence will help us easier and quickly find a behavior of a particular component, and which is a resistor. We call it the load resistor. We can use the Thevenin equivalence to calculate the current flow through it or the voltage across it. So what is Thevenin equivalence? It states that in the analysis of a load resistor contained in a complex circuit, the complex circuit can be replaced with a simple circuit like this, containing one voltage source called the V Thevenin, one resistor called the R Thevenin, and the load resistor. And they're all in series with respect to one another. And here, it's the most important part. The simplified equivalent circuit produces the same effect in regard to the load resistor as previous complex circuit. This circuit as an example, and I will explain how can we find the Thevenin equivalent circuit. So basically, it just means we need to find the V Thevenin and the R Thevenin here, and the R load is just this resistor. Okay, so first, to find the V Thevenin, there are just two steps. So first, we need to remove the load resistor from the circuit, and the voltage here at the open circuit is the V Thevenin. And the next step, we just need to use the previously learned concepts to determine this voltage. For this circuit, I will use the superposition principle because we have two power sources here. So as we said in the previous lab, we need to replace this V2 using a short circuit. So let's see, can I draw here? Okay, so once this V2 is shorted, so first we need to know that V Thevenin, because this is an open circuit, so the V Thevenin is equal to the voltage across R4 here. So once we short this V2 here, the current will go through this way, go back, then go through this way, go back. This R4 is shorted by this way. So since no current will flow through R4, the V Thevenin is equal to 0. Okay, so let's write it here. First 0, and now let's short this V1 here. Let's delete this. So once this V1 is shorted, the current will be flow through this way, and this way, then go back. So the V Thevenin is equal to the voltage across R4, which is V2 here. Okay, so we can use superposition principle to find the V Thevenin for this circuit. So next is to find the Thevenin resistance. So there are 4 steps below. First, again, we need to remove the load resistor from the circuit. And next, we need to zero all voltage and current source. So voltage source need to be replaced by a short circuit, and current source are replaced by an open circuit. Then for the third step, the Thevenin resistance is the equivalent resistance of the circuit measured from the location where the load resistance was removed. And next, we just use previous knowledge to determine the equivalent resistance. So how to find this equivalent resistance? So I will pretend this is a power source here, and the current will start from the positive and trying to go back to the negative. So for this circuit, the current will go through R2 first. Then here is a short circuit, so the current will not flow through R4 nor R1 or R3. It will just flow from here, then go back to the negative. Thus, the R Thevenin, the equivalent resistance, will just be R2. Finally, we have the Thevenin equivalent circuit here. The V Thevenin will be V2, and the R Thevenin will be this R2 here. And the last concept we need to know is the maximum power transfer concept. So again, here are the derivation. For this lab, you just need to know the conclusion that the power of the R load reaches a maximum value when the load resistance is equal to the Thevenin resistance.